Hello everyone. Today I'm going to be answering a very important question that comes up all the time, right? In the context of AI. So, what are parameters, right? You hear people say all the time, okay, this model has X amount of parameters. This model has 70 billion parameters, right? But the question is, what does that actually mean, right? Why is it important to us and why should I even care? So, let's break it down. First, a parameter is simply just a number, right? And it's a number inside of an AI model. So think about something like 0.005 or negative 1.247, right? And during training, right, the model reads billions of pages, right? And these billions of pages of text that it reads adjust these numbers to get better at predicting the next word. So each word gets tuned up a little, tuned down a little, based on the patterns in the data it's trained on. Now, here's the important thing. A parameter is not a fact, it's not a rule, and it's not a sentence stated somewhere. It's just a number. But when you have billions of these numbers working together, they encode patterns, grammar, facts, relationship between words, and even reasoning ability. So the knowledge of an AI model isn't stored as text you can read, but it's spread across billions of these tiny numbers. And this is what makes AI both powerful but also very hard to understand. So let's kind of use an analogy to try to break this down a little bit better, right? So think of a massive audio mixing desk, right? And the kind of thing that you see in a recording studio. It has hundreds of slides and dials. Each slider controls one aspect of the sound. You turn it up a notch, you get more bass. You turn it down, you get more reverb, right? So no single slider makes the song sound good. But when a sound engineer adjusts all of these things together, you get a more polished track. So an AI model is like a mixing desk with billions of sliders, right? And each parameter controls one aspect of the output. So no single parameter does anything useful on its own. But billions of them working together concurrently is is very useful, right? So training is the process of adjusting every single slider until the output sounds just about right. You feed in billions of pages of text and check how well the model predicts the next word. Then you nudge the parameters ever so slightly to reduce errors, and then you repeat that process, millions or billions of times. So by the end of training, these billions of numbers that have been tuned to encode patterns of the human language, there you have it. That's your trained model. Okay, so now let's kind of look at the scale of parameters, right? Let's understand that a bit further. So, how these models have grown over time, right? And what you can notice off the screen already is these numbers are very, very high. So back in 2019, we had GPT-4, GPT-2, sorry, right? And it had 1.5 billion parameters, right? It could write paragraphs, but they were often nonsensical. They were interesting, but it wasn't useful, right? A year later, GPT-3. Then this jumped to 175 billion parameters, right? And that's over 100 times, right? And that jump is what took AI from a party trick to something that's genuinely useful, right? It could follow instructions, write essays, and answer questions correctly. Next, we have GPT-4. And this released in 2023, as we all know, and this, you know, changed the world in a storm, right? It had easily over 1.5 trillion parameters, and it could reason through complex problems, write code, and pass even professional exams, right? And we also have some open source models like Llama Tree, which comes in so many different sizes, right? 70 billion, 500 billion. But this is important because it gives us a choice, right? Because we don't always need the biggest model depending on our task, right? And the key thing I want us to take away from here is more parameters isn't always the thing that matters, right? It's the quality of the training data, and the training technique matter just as much. So a well-trained 70 billion parameter can outperform a poorly trained 200 billion parameter model, right? Okay, so now let's understand how this affects AI, right? So how do these parameters actually affect what a specific AI model or agent can do? So more parameters means the model can recognize more complex patterns, right? It's better at nuance, right? Reasoning, handling long and difficult tasks. But at the end of the day, though, it still costs more to train. like millions of dollars, right? Cost more to run, so you need extremely powerful GPUs, and it's much slower as well. More numbers to process means longer response times. So fewer parameters can trigger much faster responses, cheaper to run, and you can even run some models locally on a laptop or a phone, right? Let's take an 8 billion parameter model, for example. It's great at simple tasks, right? Summarizing text, answering basic questions, short responses, but it might struggle with multi and complex problems, right? Problems that have more than one step involved, right? So the trade-off is real. A 7 billion parameter can run on your laptop, right? But then a 1.8 trillion parameter model might require an entire data center. So we essentially pick the size based on what we need and what we're able to spend at that specific moment in time as well, of course. So this is why we can see huge growth with cloud AI services, right? They have so many different models at different price points, and we're really paying for the parameters and the compute power that is needed to run these. Okay, so let's wrap this up, and I'll go through what I believe we should, take away home from this, segment for today. So parameters are just numbers, right? They're not facts, not rules, they're just numbers. And it's billion of numbers working together to create patterns that we as humans experience as intelligence, right? More patterns means more capable, but also more expensive and slower. Training adjusts every parameter, to minimize predictions and errors. That's the entire learning process. So the right model and size depends on your task and your budget. And remember, the quality of training data matters just as much as the parameter counts. Okay? A smaller, well-trained model can beat a larger, poorly trained one. And it's going to be very interesting to see where, the AI space goes with this. So that's parameters explained in a nutshell. Thank you for watching, and I hope to catch you in the next one.